Welcome back to our website of Table Talks. Today's sim we are going to look at partial fractions, and we are going to go to type 3 where the denominator has a quadratic factor. So with this scenario we are looking at numbers which have a quadratic number but which cannot be factorized, which has no exact factors. So examples are like x squared plus 1. You cannot factorize x squared plus 1. It is not a difference of two squares. X squared plus 5, x squared plus 4, x squared plus c the whole of it squared, and many others. All those ones are in the form of a quadratic expression which has no factors. So we are going to look at the way how we treat them, as we are going to start with the first example. Example 1 goes: express 3x plus 1 all over x minus 1 into x squared plus 1 in the partial fraction. So what I'm going to do with this, observe that the first one is linear, but this one is a quadratic which has no factors. Solution. So we are saying 3x plus 1 all over x minus 1 into x squared plus 1 is the same as, this one is linear, we're going to say a out of x minus 1 plus, this one cannot be factorized. So when it cannot be factorized, you say bx plus c all over x squared plus 1. So we go ahead and we find the LCM as usual. So this is the same as 3x plus 1 all over x minus 1 into x squared plus 1 is the same as, so the LCM is x minus 1 into x squared plus 1. The whole of this one divided by this, I'm going to remain with x squared plus 1 times a, we're going to have a into x squared plus 1, then plus the whole of that one divided by that, we are getting x minus 1 times that, we are getting bx plus c into x minus 1. Since the LCM is the same both on the left hand side and on the right hand side, so it is going to cross. We are going to remain with 3x plus 1 is the same as a into x squared plus 1 plus bx plus c into x minus 1. So we can use the covering up method, or I can use the idea of equating the monomials of the same coefficient. So what am I going to do with this? I'm going to first open the brackets, then I equate with this stuff. So we are having 3x plus 1 is the same as ax squared plus a, then plus bx times x, we are getting bx squared, bx times negative 1, we are getting minus bx, plus c times x, we are getting plus cx, plus c times negative 1, we get minus c. Now we bring those ones of having x squared on one side, we are having 3x plus 1 is the same as ax squared plus bx squared. We come those ones with x, we say minus bx plus cx plus a minus c. Now here we don't have any stuff concerning with the coefficient of x squared. So we are going to say this is 0 x squared plus 3x plus 1 is the same as, we factor out x squared. We are going to remain with a plus b x squared. Then we say plus, this is negative b plus c x, then plus a minus c. Then from there we say equating monomials of same coefficient, coefficients. So we are looking at those ones having the same coefficient in the right hand side together with those ones in the left hand side. Like here, a plus b equals 0. So we are having a plus b equals 0. This is the first equation. We are also now moving to another one. Negative b plus c, we have got negative b plus c equals, what is the coefficient here? The coefficient outside is the 3. We say this is equation 2. We also come to another one, is a minus 3, a minus c equals 1. We have got a minus c equals a 1. This is the third equation. So, can we look at the way we are going to solve them simultaneously? Solving the above simultaneously, I can say solving Roman 1, Roman 2, and Roman 3 simultaneously. So one solve them in a simultaneous way. So first look at those ones which are related. For instance, if I say equation 1 plus equation 2, so if I add the 2, b and b disappears. I'm going to remain with a plus c equals 0 plus 3, you're getting 3. I call it equation star. So we are going to solve, can say solving star with Roman 3. So if I solve those two equations, what am I having? I'm having a plus c equals 3, another one with a minus c equals 1. What if I add the 2? If I add a plus a, we are getting 2a, c plus negative c, we are getting 0 equals a 4. A alone equals a 2. After coming out with a equals 2, we are free to substitute in any of these ones to get the value of c. I can say in star, and the question is saying a plus a c equals 3. Do we know our a is 2 plus a c equals that? So what is c alone? C equals a 1. After coming out with the value of a and the value of c, we are free to substitute in any of those equations to obtain the value of b. So I can say put a equals 2 in equation 1. What is equation 1 saying? It's saying a plus b equals 0. But do we know our a? Our is already 2 plus b equals 0. So what is b? B alone is negative 2. We have come out with the value of b as negative 2. So we are going to write our equation as, we want to write our equation in the way how it's supposed to be written, which we said that it was given as 3x plus 1 all over x minus 1 into x squared plus 1, which was the same as a out of x minus 1 plus we had bx plus c out of x squared plus 1. Now, what is the value of a? We substitute in. What is the value of a? The value of a is already a 2 out of x minus 1 plus, what is the value of b? B is negative 2x plus, what is the value of c? The value of c is 1 all over x squared plus 1. We said therefore 3x plus 1 all over x minus 1 into x squared plus 1 is the same as, we can start with a positive 2 out of x minus 1. We say plus 1 minus 2x out of x squared plus 1. So you have finished expressing this into a partial fraction. Or another one, even you can go ahead and say this is the same as 2 out of x minus 1 plus 1 out of x squared plus 1 minus 2x out of x squared plus 1. All of you have already finished expressing it in the required fraction, and that's what we do when it comes to that number.